Today we are going to discuss on deflection of structures, which is serviceability criteria. So all of you know that in structural engineering we need to deal with a lot of parameters, like we can say there is a stability. I think all of you know, we make sure that our structure is stable, that is stability criteria. Second point is serviceability, that we are going to discuss today. And third point is, we can say, strength. In stability we deal with the structural system which is stable and the structure will not collapse. I think we have done one workshop, one or two workshops last time on the stability of structures. Today we are going to discuss on serviceability of structures, where the major point or major criteria is deflection. So there are different IS codes available for that. And third point is strength, where we check the stresses in the members. So third point we are not taking, we are only discussing today the serviceability criteria. And there the deflection is very much important. So can anybody tell me what is deflection of structures or why it is important? Anybody? Can anybody discuss with me? Why deflection is important in structures? Calculation of deflections. Hello? Hello?
Hello.
Yes.
Sir, sir, to make sure that the failure doesn't happen suddenly and there is certain limit to the deflection.
Right, because see, deflections are important in different structures in different members. For example, let's try to understand the importance of it. Let's say we are having one bedroom in which there is a beam like this. Okay, say this is a bedroom or living room, whatever you say. And if this beam deflects like this, let's say, and if I say that the deflection is there is no problem to the safety of the structure and the building or this room will not collapse. Structural designer has designed the beams and he is saying that it is safe, and definitely it can be safe because strength criteria is satisfied. That means this will not crack or there will not be any extra stresses in the members or beams. But still it is deflecting like this, let's say 4 inches or let's say 100 mm. So is it really good to stay in such kind of room? Will you be feeling safe staying in such a room? What do you say? Hundred deflection is there in this room for that beam. So is it really giving you the feeling that I should stay in such kind of room, even though I say that it is safe? So there definitely this is called as the serviceability. One will not like to stay in such kind of room. There is a deflection, more deflection in this, and when there is a more deflection, then we feel that it is having a stability issue. Okay, so there is a fear in mind that the structure will collapse. So this fear, or I can say the feeling, is also one of the important parameter in deflection of structures. One is feeling, where we stay. Second is, we can say, functional criteria. See, all of you know that for example, let's take example of gantry girders where there are cranes running, and if the cranes are running and if the deflection is more, then there is a possibility that crane will fall down because there will be slippage of the wheels from the rail because there is a more deflection. So functional criteria is also important, and that's why the serviceability criteria or deflections are important in the structures. Okay, so we will see one by one what kind of deflections are there, and today's session is just to understand the importance of the deflection of structures and what kind of deflections are there in the structures. Okay, and what IS codes are there so that you will get a feel. And most of the times I have seen that this criteria is ignored. See, many times structural engineers, generally the beginner people, they are not aware of the deflection. Say what they will do, they will design the beam. Generally in the structural engineering office, people design the beams, columns, slabs, footings, like that. So they will design and they will put the reinforcement in the beam. Let's say this beam is there and the beam size is say 500 mm deep, 230 mm wide. Okay, and the span, let's say it is say 8 meters. Okay, 8 meters I am saying, 800 mm, 8000 mm. And he is designing this and he is putting the extra steel. As you know that the depth is less, so there will be more steel. So they will put more steel, let's say 60-25 mm bars. Okay, now if you design the beams, design is okay, there is no problem, design is okay, design is safe, and they ignore the deflection checks. They don't check the deflection, and then in future there is a possibility of more deflection in the structure, even though it is not failing, because there is enough steel in the beam. There is grade of concrete is also good, so structure will not fail, but it will deflect more. So this is the problem. Now this is most of the times ignored by the structural engineers in the beginning. Actually they forget to check. Many times architect will force you to reduce the depth. What happens, architects demands us that I want less depth because there should not be more offset in the room or in the structure. So they will say that I want only 500 mm depth. So for 8 meter span, 500 depth is really less, very less. Okay, and this will create deflection issues, and in future there will be more deflection in the structure. So this criteria is very much important. Even though you put more steel, less depth is not accepted, because less depth the deflections are more. Okay, so this is the overall idea. So for 8000 or mm or 8 meter span, the depth should be something 750, 800 like this. Okay, so general criteria is L by 10, general L by 10 to L by 12, let's say. Thumb rule I can say, just to start with any size of the member. So if the architect is asking you or forcing you to reduce the depth, make sure that the deflection are within limit. So generally these deflection limits are given in the IS code for steel structures or RCC structures. So 100 mm is definitely not acceptable. Then IS code may say only 20 mm is acceptable. So there are permissible limits for the deflections given in the IS code. So if the 20 mm, so you are getting 100 mm, so what you will do, instead of 500 you will go for, let's say 230 by or 300 by, let's say width also you can increase by 750. Now this size may satisfy the deflection limits. Okay, so this is the overall. Definitely whenever you increase the size, the steel will be required, will be less. Let's say only 3T25, because depth is more. So it doesn't mean that you increase the size, that means you are increasing the concrete. You are reducing the steel also. So increasing the size of the member, size of the beam or thickness of slabs, there is no issue. It is really good to increase the size instead of increasing the percentage of steel. So this is the overall importance of the deflection of structures. Now we will see the types of deflections. So there are different types of deflection. Axial deflection, that is called as a column shortening. Generally in high-rise buildings, the axial loads are more in the columns, and the column along the axis may shorten, so it will reduce the length of the column, and there are problems due to column shortening also. We will see how it looks. Then there are vertical deflections. So you can see this beam, when there is a load on the beam, then there is a deflection. This is called as the vertical deflection because this direction is vertical. So beam can deflect like this, or slab also can deflect like this. So any horizontal member, beam or slab, will deflect vertically. So this is called as the vertical deflections. Then lateral deflections. So all of you know that due to earthquake or wind loads, the building sways to the right or left, or laterally we can say. So that is called as the sway of the building or drift of the building. That is called as the lateral deflections due to earthquake or wind loads. Then angular deflection, that means rotation. So I'll just show you. Axial deflection means If this is a column and there is a load on the column, then column length will reduce. There is a shortening of the column, delta. So this will move. This is axial deflection. Vertical deflection, as I told you, if this is a beam, then it will deflect. So this is called as the vertical deflection, delta V, let's say. Lateral deflection, if this is a frame or building, let's say, and there is a lateral load, then due to the lateral load, this will sway like this. So this is called as the horizontal deflection or lateral deflection, delta S, let's say. Angular deflection, rotation or overturning. So all of you know that if there is a high-rise building like this, due to the horizontal loads like earthquake, the building may sway or it will rotate. So there is a rotation here, theta. So the building rotated like this. This is called as overturning also, rotation or overturning. Even in the retaining walls, all of you know that retaining walls, there is a soil pressure on the retaining wall like this, and this will bend like this. That is called as the overturning or angular deflections. Then there is torsional deflection. Torsional deflection means if this is a building in plan, then building can twist like this, twisting or torsion. And then short term and long term deflections are there. Then relative drift or interstory drift we can call. We will see this. And there is a buckling of columns. Okay, so we will see one by one in general. So you should be aware of all these kind of deflections, and as per the situation of the structure, you should know that what kind of deflection will be there in the structure, and you should design the structure and members so that whatever deflections are coming in the structure, they should be within limits given by the codes. They should not be more than the given in the code. Okay, and the reasons or causes of the deflections are gravity loads. So all of you know that gravity load means dead weight of the structure, like dead weight of concrete in like slab beams. So due to that dead weight, there may be deflection in the beams and slabs. There is a live load also on the structure, all of you know. So due to live load also, there is a deflection. So definitely we can say that due to the loads, there is a deflection. Okay, loads or forces. Reason of force may be different. Then wall loads, all of you know that generally walls are on the beams. So due to the wall load also, beam will deflect. Then earthquake loads. So all of you know that earthquake load is due to the inertia. If this is a mass and let's say this is your building, then there is acceleration due to the earthquake in the horizontal direction. This will oscillate. So you can say there is a deflection, horizontal deflection, earthquake loads. Why? Because of force is equal to ma in the horizontal direction. So this building will sway horizontally due to the earthquake loads. Wall loads, you know, it is vertical due to the dead weight of the wall. Wind load, you know that wind load also, if this is a high-rise building, then on the surface of the wall or on the surface of the building, there is a wind pressure, and due to the wind pressure, the building will sway horizontally like this. So this is wind load, reason of the deflection. This is your deflection of the building. Deflection due to fire also. Due to fire, actually the material property gets changed. The modulus of elasticity E changes, and due to that there is a deflection in the fire. Deflection due to temperature. So you know that deflection, there is a deflection due to the temperature also. So if there is a more temperature, the length of the member will increase. So let's say this is your original length. Due to the temperature, this will increase. Once you hit this member, let's say this is a steel rod. Previously the length was this, original length. After hitting the rod, proportionately there is a change in temperature. So generally deflection due to temperature means change in temperature, original temperature and final temperature we can say. So that is also a reason of the deflection. Then deflection due to compression, buckling. Okay, so let's say there is a column, we are going to see in detail also. If the column is very slender, let's say very thin, and if you apply the load on the column, compression, let's say, after a certain point, as you go on increasing the load, suddenly this will buckle. So even the column is having enough capacity as far as the cross sectional area is concerned, but it will buckle. This lateral deflection is called as the buckling due to the compression. Generally buckling is due to compression, and deflection due to overturning. So I discussed with you retaining walls or due to earthquake load there is a overturning. Okay. Now you can see different deflections. I will show you certain photographs where you will understand why it is important. So you can see here this structure. This is a real structure actually. See, you will see such kind of problems in real projects. It may be for old structures or even for new structures. If you see this photograph, you can see there is a curvature here. See this bottom part of the beam. Even this slab is also deflected, right? So there are reasons of deflections. You can see actually there is some problem regarding the support here on the column. The column is, there is no RCC column, there is only brick column. So this person, or see, this might not be designed as by the structural engineer. So generally such kind of non-engineering practices are there in the market where there are no engineers. So such kind of problems you will see due to non-engineering structures. So this depth of the beam is not sufficient, D, and even thickness of slab may not be sufficient, and there is a problem of the support. So the support got settled. So there are many reasons of the deflection of the structures. First of all, you should be aware of this. Today's session is to have the awareness of this term deflection. Okay. Now you can see here deflection of beams, and even after the deflection there are major cracks we are observed. So that means it got slipped from here. So that means there is no sufficient connection to the slab, and that's why there was a gap and the beam got deflected. Even this supporting condition is not proper. So whenever you understand the deflections, first of all you should know how it deflects, and second you should know what is the reason of deflection. So there is maybe anchorage issue first, and then there is a supporting condition, fixed or pinned condition we do. There are no sufficient supports here, for example. Then now you can see deflection of cantilever beams. This is very, very important. Cantilever beam, whenever you design any cantilever beams in RCC or steel structures, the deflections are more. For cantilever structures, they are very high. This delta is very, very high. If it is a simply supported, it will be less, definitely. Simply supported deflections are less, but cantilever deflections are very high. And there is a danger of the safety, danger to the safety of the structure. Let's say there is a wall here, then this wall may fall down, or there may be large cracks in the wall, okay, due to more deflection. Due to this deflection, there are cracks in this beam also, okay. So many times what happens, this cantilever beam is there, but there is no backup beam here. If there is no backup beam, then what will happen? Then this column will overturn. There will be moment in the column, and this will overturn, and this will deflect more, and will have more cracks also in the structure. So you know that if there is a cantilever in structures, we generally provide backup beam like this. So if there is a load, then this backup beam acts as a balancing member, so that there will not be rotation of the column. If you see here, let's say I'll show you. See, try to understand. I'm not going to discuss much about the calculations, but try to understand the behavior of the section. Let's say this is a cantilever resting on the column, and if there is a load, either UDL or point load, then what will happen? This will deflect. Even this column will deflect, okay. Now this deflection is more. Why it is more? Because column has no capacity to take this overturning moment. So there is a overturning moment or bending moment in the column which cannot take the load, which cannot take the, we can say, rotation, and it will directly overturn like this due to this. That means there is a problem in this. So many times you will see the structures in practice where there is no backup beam and there are more deflections in the cantilever beam. So the solution for this, I can say, try to provide backup beams. If there is a cantilever, there has to be one backup beam here like this. Okay, then definitely the deflection will be less, we can say, within the permissible limits. There will be deflection, but within limits, and this deflection gets balanced here in the backup beam. This is called as the backup beam, and the column will not rotate much, we can say. So these are the important points which you should consider. And second point is that support should be fixed. If the support is pinned, then it will fall down. The deflection will be so severe that it will fall down. So I can say for deflections of the cantilever, the supporting condition is important, first point. Second point, there has to be backup beam to balance the load and deflections. Now you can see there are deflections in this chhajja. You can see due to the fire there are deflections observed. See this. Just a moment. See this, there is a deflection here. Okay, let's say this is your original position. Due to the fire, the reason is, in fire what happens, the modulus of elasticity E, this is very important in deflection, modulus of elasticity. If it is less, deflection is more. What happens in fire, the E value gets reduced. It will reduce due to the fire because the material properties will change due to the fire, due to heat, and there will be more deflections. Definitely they are not in our control because fire is, we can say, emergency case only. Now here also you can see, due to fire, the steel structure, there are a lot of deflections of different varieties. There are buckling, there is a vertical deflection, local buckling here you can see. So these are the deflection you can see in the fire condition.